Hypothesis test. Difference between two means. Hypothesis tests can be used to test a claim, allowing the statistician to make a decision based on data. All hypothesis tests should be followed in a matter of steps: state, plan, analyze, and conclude.
First, state the test being used and state the claims. In a hypothesis test, difference between two means, we have three options with our null and alternative hypothesis. They are listed below.
2. Planning describes how to use sample data to accept or reject the null hypothesis. It includes the test being used, such as two-sample t or z-test, and the significance level being used in the test. Oftentimes, when a significance level is not given, it is a universe point to use a level of 0.05. The test statistic for hypothesis tests can be either of the formulas shown below.
3. Analyzing the data includes calculations to find the degrees of freedom, standard error, standard deviations, the test statistic, as well as the p-value. Visual graphs should be included to support your numerical data.
Concluding is the summarizing of your findings after the test on your data has been completed. It involves comparing your p-value with your significance level. If the p-value is the probability of observing a sample statistic as extreme as the test statistic, and if this value is below the significance level, we reject the null hypothesis.
It is very important that we include the conditions with our hypothesis test before actually performing the test to make sure that our data is able to be considered a normal distribution. The conditions for this type of test include: first, the SRS. The two samples are an SNS from their respective populations or are two groups in a randomized experiment. Second, normality. If both populations are normal, or N1 and N2 are both greater than 30, the sample distribution of X bar 1 and X bar 2 is normal. Third, the large population. N must be greater than or equal to 10N1 and 10N2. If so, the standard deviation of X bar 1 minus X bar 2 equals radical standard deviation 1 squared over N1 plus standard deviation 2 squared N2.
Tip: do not pool data. Now, let's try an example problem. Does increasing the amount of sodium in our diet increase blood pressure? The relationship was strongest for Latino men. Researchers designed an experiment with an SRS of 21 Latino men who were randomly assigned to two groups. 10 men were sent into the sodium group and 11 went into the placebo group. The response variable is the increase in systolic blood pressure for a subject after 12 weeks in millimeters of mercury. Do the data provide sufficient evidence to conclude that a sodium supplement raises blood pressure more than a placebo? Alpha equals 0.05.
First, show your conditions, and then list your claims as shown below. Let sodium equal 1 and placebo equal 2.
The t-star value equals 1.604. From this we can find the p-value, which equals 0.0715. Because the p-value is greater than alpha, which is 0.05, we can then make our conclusion. We fail to reject HO because the p-value is greater than our significance level, so we must reject the null hypothesis. This provides evidence that sodium does increase blood pressure.